This presentation is part of the TI in Focus AP Calculus video series. In this video, I'll discuss the scoring guidelines for the 2019 AP Calculus exam, free response question BC6. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading in Kansas City. I'll present a brief general summary for student performance on this question, and then I'll consider more detailed interpretations of the scoring guidelines and how these guidelines were applied in certain situations. I'll consider some common student errors where it's relevant, and where appropriate, I will present some specific scoring examples. This free response question involves a function f with derivatives of all orders. A portion of the graph of f is given, along with the tangent line to the graph of f at x equals 0. And there is also a table given which lists selected derivatives of f at x equals 0. In Part A, we need to use the information given to write the third-degree Taylor polynomial for f about x equals 0. In Part B, we need to start by writing the first three non-zero terms of the Maclaurin series for e to the x. Then we need to use this result and the result from Part A to write the second-degree Taylor polynomial for e to the x times f of x about x equals 0. In Part C, a new function h is defined in terms of a definite integral. We need to use the Taylor polynomial found in Part A to find an approximation for h of 1. And finally, in Part D, we need to use the alternating series error bound to show that the approximation found in Part C differs from h of 1 by at most 0.45. Part A was worth 2 points. The first point was for any two correct terms of the third-degree Taylor polynomial for f about x equals 0. And the second point was for the remaining terms. Part B was also worth 2 points. The first point was for the first three non-zero terms of the Maclaurin series for e to the x. And the second point was for the second-degree Taylor polynomial for e to the x times f of x. Part C was worth 2 points. The first point was for finding the antiderivative, and the second point was for the correct answer, that is, the approximation. Part D was worth 3 points. The first point was for using the fourth-degree term of the Maclaurin series for f. The second point was for using the first omitted term of the series for h of 1 in finding the error bound. And the third point was for explicitly indicating the error bound. Here's a general summary of student performance on this question. In Part A, most students were able to find f prime of 0 from the given graph. However, there were some students who simply could not make use of the graph to find f prime of 0 or f of 0. Now, most students used good notation in Part A in presenting the pieces of the Taylor polynomial. However, unfortunately, there was some misinterpretation of the phrase or the term third degree. Some students presented three non-zero terms, and some presented only the degree 3 term. In Part B, many students knew the first three non-zero terms for the Maclaurin series for e to the x. However, some students presented an alternating series for e to the x, and some omitted the constant term. To find the series for e to the x times f of x, some students actually went back to the general formula for a Taylor polynomial, and therefore they needed derivatives. So some students tried to differentiate this product repeatedly and evaluated x equals 0. The most common error in Part B, unfortunately, was associated with multiplying two polynomials. And several students did not collect like terms to present their final answer as a Taylor polynomial. In Part C, most students were able to find an antiderivative of a polynomial and correctly evaluate the resulting function on the interval 0 to 1. The most common error in Part C was a misinterpretation of the integral. Some students actually read this as a simple evaluation symbol, and they evaluated f at x and 0. In Part D, many students had trouble connecting the error bound and 0.45. Some students tried to use the Lagrange error bound, and some students indicated that the actual error was 0.45. Unfortunately, many students used inconsistent or undefined notation in Part D. Part A was worth 2 points. 1 point for 2 correct terms, and 1 point for the remaining correct terms. Now, in general here, we're looking for a correct degree 3 polynomial. The first point is for 2 correct terms in the degree 3 polynomial, and the second point is for all remaining terms presented. Here are some example student responses and how each was scored. In example 1, we have 2 correct terms, and the remaining terms are all correct. Note that the numerical part of each term does not need to be simplified. So this response earns both points, or 1-1. In example 2, the denominator in the last term is simplified. So there are 2 correct terms, and the remaining terms are correct. This also earns both points. In example 3, even though f of x is not equal to this degree 3 polynomial, we read the equal sign as approximately equal, so this earns both points. And in example 4, there are 2 correct terms, but the remaining terms are not correct. It should be minus 2x, so this earns 1-0. Note that in Part A, if the student presents any terms beyond the cubic term, they do not earn the second point. And here are some examples. In example 1, the student has presented an extra term involving x to the 4th. They do have 2 correct terms, so they earn the first point, but not the second. In example 2, there are 2 correct terms, but the 3 dots indicate additional terms, in fact, infinitely many additional terms. So this also earns the first point, but not the second. The first point in Part B was for the first 3 terms of the Maclaurin series for e to the x. And here's the general philosophy in scoring this problem. We must see an explicit expression of the first 3 non-zero terms. If there are more than 3 terms listed, we will read only the first 3 non-zero terms and ignore the rest. Now, the 3 terms may appear in a list, not as part of a sum. If the student presents just general sigma notation for the Maclaurin series for e to the x, they do not earn this point. And an implicit expression and use of the first 3 non-zero terms of e to the x, usually as part of a product, does not earn this first point. Here are some examples of student responses, focusing on the first point of Part B and how each was scored. In example 1, the student has the first 3 terms and has the sum equal to e to the x. We'll read this as approximately equal, so this earns the first point. In example 2, those are the first 3 terms. No explicit identification is necessary here, so this also earns the first point. In example 3, the 3 dots indicate more terms, but we read only the first 3 non-zero terms. So this earns the first point. Similarly, in example 4, there is an extra term, but the first 3 are correct. This earns the first point. In example 5, the 3 terms are listed, not part of a sum, and that's okay. This earns the first point. In example 6, this is the entire Maclaurin series for e to the x, written using summation notation. We don't have the first 3 terms explicitly presented. So this alone does not earn the first point. Now note that the student could go on to extract the first 3 terms to earn the point, but they have not earned this first point yet. And finally, in example 7, the first 3 terms are implicit in the product. They are not given separately or explicitly. So unfortunately, this presentation alone does not earn the first point. The second point in Part B was for the 3 terms in the second-degree Taylor polynomial for e to the x times f of x, about x equals 0. So this point is earned for the correct second-degree Taylor polynomial, and the product must be completed. The second-degree polynomial must be presented. Now, this is not a final numerical answer, so we need to see the second-degree polynomial, and that means that the terms must be collected. Now, we did have a special consideration for students who used 3 dots in both Parts A and Part B, and we made sure that these students were not penalized twice here. And there was also a special case, and without going into the scoring details, this involved a student who made an error in the first 3 terms of the Maclaurin series for e to the x. Here are some examples of student responses, focusing on the second point of Part B and how each was scored. In example 1, the correct final answer is given, but the first 3 terms of e to the x are not present. So this earns the second point. Now remember that the question mark in the score off to the right here means that the student has not lost the point, but could go on to earn the point with further work. In example 2, again, we will read the equal sign as approximately equal. So this earns the second point. In example 3, let's suppose that this is all that is presented. The student has not explicitly conveyed the 3 terms for e to the x, and they have not multiplied out and collected terms to present the Taylor polynomial. So this response alone earns 0, 0 in Part B. In example 4, the numerical parts of the polynomial do not need to be simplified, so this earns the second point. And in example 5, this does not earn the second point yet, because the terms need to be collected in order to present a Taylor polynomial. The first point in Part C was for the antiderivative. In this example, you can see that the student has the correct antiderivative. They do not have to evaluate to earn this point. Now, theoretically, the student has presented the polynomial in Part A. Therefore, we do not require integral notation here. The student could simply write the antiderivative, presumably by looking at the polynomial in Part A and applying the power rule. If there is only one error in the antiderivative, the student does not earn the first point, but we will read with them for the answer point. And if there are 2 errors in the antiderivative, the student does not earn the first point, and they are not eligible for the answer point. So this would earn 0, 0. The second point in Part C was for the answer. So this point is simply for the correct answer. And this was a final numerical answer, so it does not need to be simplified. If there is no evidence of any integration, the student is not eligible for the answer point. And if the student attempts to simplify, it must be correct in order to earn the answer point. Linkage errors in the antiderivative, that is, unequal expressions connected with an equal sign, do not earn the answer point. Without going into the scoring details, it was possible for a student to import a degree 3 polynomial from Part A if it had at least 2 non-zero terms. The student could still earn 2 points in Part C. And there was a special case here, as mentioned on the previous slide. If there was one error in the antiderivative, it was possible to still earn only the answer point. The first point in Part D was for using the 4th degree term of the Maclaurin series for f. Now this means we need a term in a power series, and we need evidence of antidifferentiation of the 4th term of the series for f. And this term may appear in a polynomial or a series. Here, the first point is earned for correctly using the 4th degree term of the series for f. There does not need to be an explicit integral sign to show evidence of antidifferentiation. Each of these expressions earns the first point. If there is an error in the antiderivative, the student does not earn the second point. So each of these expressions conveys the use of the 4th degree term, but there's an error in the antiderivative. So each earns 1 0 and is eligible for the third point. Now the term may appear in a polynomial or a series, so this expression earns the first point. The second point in Part D is for using the first omitted term of the series for h of 1. So the student could use the 4th degree term of the Maclaurin series for f and other terms. But to earn this second point, they must explicitly use the first omitted term for h of 1. Now, this means we need evidence that the student is evaluating the correct 5th degree term of h. If there are any errors in antidifferentiation, the student does not earn this point. And the student must clearly commit to this term. Here are some examples that earn the second point. Notice that this example earns the first 2 points. The student is using the 4th degree term of the Maclaurin series for f, and they are using the first omitted term of the series for h of 1. To earn the second point, the term cannot be part of a polynomial. So this expression earns the first point, but not the second yet. And if there is a linkage error, the student does not earn the second point. The third point in Part D was for demonstrating the error bound. Now, there must be an explicit reference to the error. The reference can be the word error, or it can be conveyed in another way verbally or in symbols. But the student must make a connection between the error bound and our stated value of 0.45. Here are some example student responses, focusing on the third point and how each was scored. In example 1, the student has made an explicit reference to the error and connected this to 0.45. In addition, we can see the first omitted term of the series for h of 1. So this earns the second point and the third point for sure. And there may be other work that could earn the first point. In example 2, this is just another common way to refer to the error and make the connection. So this also earns the second and third points. In example 3, the student uses the first omitted term, but has not made an explicit reference to the error. So this earns the second point, but not the third. And in example 4, the student also uses the first omitted term, has referenced the error, but has not connected this to 0.45. So this earns the second point, but not the third. At the AP Calculus reading, an actual briefing for the scoring of a free response question usually takes approximately 75 minutes. And there is also time allotted in the reading rooms for discussion before the actual scoring begins. However, I hope this summary video gives you a good idea of how this question was scored. And just a reminder, there are lots of valuable resources on the TI website. There is material there involving technology and calculus, classroom activities, and lots of calculator tips and tricks for test success.